Morning everyone, it's a fantastic morning here at Welshpool. At the moment the airfield is quiet, with a lone C-172 inbound to land from Sleep Airfield just east of here in England. So let's turn on our radio for a moment and listen in to the air traffic control.
Welshpool radio, Golf Sierra Hotel Sierra Papa, inbound from the northeast, range 10 miles, height 3,000 feet, field in sight, request airfield information.
Golf Sierra Hotel Sierra Papa, Welshpool radio, runway 04, left hand in use, wind 050 at 7, QFE 1001, QNH 1011, circuit is empty, report overhead.
Runway 04, left hand, QFE 1001, QNH 1011, and Wilco, Golf Sierra Papa.
Unfortunately today we will not be taking to the sky, we have some important basics to get out of the way first. So let's get stuck in. In this video we will look at the basics of the aircraft. We will go over the fundamentals, and if we throw a certain term at you later on in the course, you can always refer back to videos like this one. So let's begin. As we have said before, there is a fair amount of variation between training aircraft, but they all share the same fundamental attributes. Let's look at some now. First, we should look at a plane's most important feature, the wing. You might think most or all wings are generally the same, but the shape and features of a wing are crucial in the performance and safety of an aircraft, whether it be a Cessna 172 or a Concorde. Let's have a look at some examples. We have a common high wing configuration, and a low wing configuration, and also a mid-wing configuration. As you can see, our Cessna 172 comes into the high wing category, but other trainers such as the Piper Cherokee and Diamond aircraft come into the low wing configuration. It's important to note that without wings, an aircraft is not an aircraft. The engine pulls the aircraft through the air, to be sure, but the wings still provide lift and allow the aircraft to fly, even if the engine is not present. This, of course, is gliding. But it's a good point to be making at this stage of understanding. But we can talk more about engines later. For now, let's take a closer look at the wing. On the 172, we have the leading edge, the wingtip, the trailing edge, and the wing root. On low wing trainers, you will often see a black strip of grippy material close to the fuselage. This is the walkway you use to actually get into the aircraft from outside, but the 172, we don't have that. Instead, we have little footplates that help you get into the aircraft safely. If we look at the cross-section of a wing, we can see the control surfaces are usually on the trailing edge of the wing. Some aircraft have slats or high-lift devices on the leading edge, such as larger aircraft that have more complex flap controls like a Boeing 737. Also, in our C-172, you can see that the engine is not mounted on the wings, as they are in multi-engine aircraft. Now let's move on to the tail section of the aircraft. Much like the wings, the tail has a variation of designs. The C-172 has a low tailplane design, as opposed to some aircraft like this, that have a high tailplane design. The tail, like the wings, is comprised of a set of fins that stick out from the fuselage to provide stability and control in flight. Here we have an example of a vertical stabilizer and a horizontal stabilizer. The similarity with the wings continues as we notice that the control surfaces are found on the trailing edge of the surface rather than on the leading edge. We could stop there and say we have gone over the basics of an aircraft, but there are more things to look at. Now, let's go to the undercarriage. The undercarriage of an aircraft is crucial in allowing the plane to land safely again and again in a wide variety of landscapes, from rough ground to smooth, from land to sea. Our C-172 has what is called tricycle gear or nose wheel gear. The more traditional design would be tail wheel gear. The tail wheel configuration is seen as the classic design for aircraft of an earlier period. During the development of modern aircraft, it was found that having a nose wheel configuration gave a pilot much better visibility over the nose of an aircraft when on the ground. The next point we will look over is the engine of the C-172. Since we're going to fly this aircraft exclusively through the course, it makes sense for us to take a closer look at the engine at this point in time. Here we have a Lycoming IO 360. This version of the C-172, the R version, was the first to have a fuel-injected engine. One of the perks of this is that you don't suffer from carb icing. This isn't a problem for you because a non-fuel injected engine isn't solely fed by gravity, but by the carburetor that uses a venturi to suck fuel into the engine. The air-cooled engine has a lifetime of 2,000 hours, or 12 years. It has 4 horizontally opposed cylinders and produces 180 horsepower. In the simulator here, the A2A simulation C172 has been modelled with these individual cylinders, along with individual replaceable engine components, so this is going to be fantastic for learning the basics of engine maintenance as well. Now, before looking at the interior, let's familiarise ourselves with the aircraft control surfaces. The primary flight controls of the aircraft are the elevators, ailerons, flaps and rudder. There's a few external variations in control surfaces. This is mainly down to the different aircraft designs. For instance, the Piper Cherokee 180 has an all-moving tailplane or stabilizer, while the C172 has the elevators split across its 2 horizontal stabilizers with a trim tab on the right-hand side. Another basic difference we see at this stage is that some trainers have flaps that are electronically operated and others have flaps that are operated manually, either with a stick or a wheel. We don't need to go into the details about these since we will cover the operation of control surfaces later. I know this video has already featured quite a lot, but we still have more to cover. We now are going to look at the interior of our training aircraft. The interior of the C172 is much like other small single-engine aircraft. We have 2 front seats, one for the pilot flying and one for the secondary pilot or the instructor. The instructor usually sits right seat in the C172 while the student will be sitting left seat with the full control panel. So our course will be conducted all from the comfort of the left seat. The side of the gear strut has footpads for you to safely climb into the aircraft without exerting pressure on a part of the aircraft that could be damaged over a long period of use. As we climb in, we can see our foot pedals. These are our rudder controls, and if we push them forwards with our tiptoes, it activates the brakes of the aircraft. Moving up, we can see our control column. This is sometimes called the yoke or the stick. This is a push-pull configuration, and other aircraft will have an actual joystick that pivots from a central point. But this yoke moves in generally the same intuitive way: up, down, left, right. Next, we will move on to our gauges. In the C172, we have steam gauges, and in a more advanced aircraft you might see a glass cockpit, which we will talk about in a moment. Our 6 most important gauges are located just above our yoke, in the most visible location for us as pilot in command. Here we have the airspeed indicator, the attitude indicator, the altimeter, the turn indicator, the heading indicator, and finally the vertical speed indicator. These 6 are crucial to the safe control of the aircraft in flight. You could fly the aircraft with only these 4 gauges in a VFR condition, much like a Piper Cub, but for greater awareness and the ability to fly in IMC, we will have these 6. This is the bread and butter of your control. However long you spend in the aviation world, when you fly an aircraft, you will always be living your life by these instruments here. They may be bigger or smaller, they may be steam gauges or in a glass cockpit configuration, but the basics remain the same. Once you learn to fly a C172 with these instruments, you are able to pilot this aircraft, and potentially many more to come. Let me finish off this video by taking a look at 2 systems that help keep the aircraft in the sky. The first, and most important for powered flight, your fuel system. The second is the electrical system. The fuel system supplies aviation fuel from your tanks to the main engine. In this case, we only have 1 engine and 2 tanks. Our 2 tanks are located in the wings above us on each side of the aircraft fuselage. You can see the 2 small hatches used to refill them when they are low. The fuel system can be as simple as a tank above an engine that is gravity-fed, such as the Piper Cub. The fuel system can also be as complex as that on the Concorde, an aircraft that has to be continually pumping thousands of gallons of fuel from one tank to another to maintain its delicate center of gravity when it's flying at Mach 2. In the case of this specific variant of the C-172, as we've said before, our engine is fuel injected, so no gravity-fed tanks here. Okay folks, I promise I'm almost done, but let's take a look at the electrical system quickly. As you know, the electrical system in the aircraft is not 100% critical. If you have an electrical failure in the air, as long as you can maintain VFR conditions, you can use your control surfaces and your running engine to fly to an airport and land safely, with the aid of your steam gauges, which shouldn't be affected by the loss of electricity. Although having said that, the electricity is crucial for those more advanced systems like the Bendix King autopilot, and let's not forget communicating with air traffic control. Our radios and VOR navigation would go dead if we lost electrical power. In our C-172 we have an RG2411M. If you're using the A2A simulation C-172, you can actually go into your maintenance hangar and change out different components to suit your needs. The electrical system is turned on and off via the master switch. It provides electricity to the lights, some instruments, autopilot system, and radios, as we have said previously. Also, note that in the high-wing aircraft, the flaps are usually electrically driven. A series of circuit breakers can be found in the aircraft which show when one of the electrical lines has been tripped. This is helpful when one day you start the aircraft and can't find out why something doesn't work. Always give a visual check along this row. Also remember that when starting your engine and turning your magnetos to both, you are sucking up a fair amount of battery power. So if you are starting your engine on a cold day and it takes a while to start, you start to run the risk of emptying your battery to the point where the starter doesn't get enough power to work. A good point to note here is that the spark plugs do not take their power from the battery. The spark plugs take power from the electricity generated by electromagnetic induction from the magnetos. This point also backs up the fact that we mentioned earlier about the engine working without the need for the battery's electrical power. This covers all the main points of our aircraft familiarization. While watching through this video series, it would be a good idea to keep the A2A Simulations C-172 PDF manual with you, maybe print it out into a binder or have it open on a separate screen. Get familiar with the sections of the manual, and I challenge you to read it through from cover to cover at least once. Then later you can go back and pick out specific parts that are helpful to you. Thank you for staying all the way to the end of this video, and in the next one we will be picking up with a small video on emergency procedures, and then after that we will be looking into preparing for a flight and what to do after successfully completing one.